urgent, ticking drumbeat music and narrator. Look at this skyline, 101 stories. 492 meters of steel and glass piercing the thick haze of the Pudong Financial District. To the casual tourist looking across the Huangpi River from the historic Bund, it is a monument to unbridled economic power. The crown jewel of a multi-billion-dollar master plan to turn what was once muddy farmland and rice paddies into China's Wall Street. They call it the bottle opener, a structural marvel with the highest occupied floor on the mainland, designed to channel the immense wind loads of the East China Sea through a massive, hollow aperture at its summit. But behind the gleaming curtain wall lies a structural crisis that nearly left this mega-project dead in the mud. A story of a soaring engineering ambition that slammed into a brick wall of cultural memory, financial ruin, and a mathematical redesign that defied the laws of physics. This wasn't just a building. It was a $500 million gamble that ran completely out of money, sat as an abandoned, waterlogged foundation pit for nearly a decade, and was then forced to completely alter its physical shape mid-construction because of a symbol.sound effect. Dramatic reverse cymbal boom. Imagine climbing past the 80th floor, looking up at the clouds, and realizing that the very shape of the mega tower you are building has sparked an international firestorm. An entire metropolis looked up at the sky, saw something it could neither forgive nor forget, and demanded the builders stop. The problem wasn't the concrete grade. It wasn't the column-to-beam joints. The problem was a hole, a massive 46-meter wide circular void cut through the top of the tower. To the engineers, that circle was pure mathematics. An elegant moon gate, inspired by classical gardens that would bleed off the destructive aerodynamic forces, trying to twist the building apart during a super typhoon. But to millions of citizens in Shanghai, that circle looked like something else entirely. It looked like a foreign rising sun, a nationalist emblem stamped onto the sky by an elite development team, hovering over a city that still bore the raw, unhealed scars of 20th century warfare, construction ground to a halt. The structural blueprints were ripped apart, and the master planners had to scramble to answer a question that no engineering degree in the world prepares you for. What is the difference between a circle and a square when a nation is watching? Music shifts. Dark, driving synth beat. How does an aerodynamic wind vent become a crisis of national identity? How do you push a tower 32 meters higher than it was ever designed to go, when your massive concrete foundations are already permanently set in the unstable deep silt of the Yangtze River Delta? To understand how this architectural titan nearly collapsed under the weight of its own meaning, you have to go back to a city that no longer exists. Rewind to the late 1980s and early 1990s. While global markets were staggering from structural shocks, the mainland was experiencing an urban explosion never before seen in human history. A staggering 300 million people were moving from rural provinces into urban centers. Shanghai was designated as the ultimate engine of this new era. The Municipal Construction Commission drew up a bold blueprint: turn 80 pristine plots of Pudong mud into a dense forest of ultra-high-rise office blocks almost overnight. And at the absolute center of this gold rush stood 3 designated super-tall plots, 3 giants that would define the skyline for the next century. Sound effect. Metal Kleng Plot 1 was already claimed. The Jinmao Tower was rising, a brilliant, tiered structure modeled after a traditional Chinese pagoda, showing the world how regional history could be fused with modern structural engineering. But for the second plot, a prominent domestic tycoon named Chairman Li wanted something radically different. He didn't want a replica of the past. He wanted a hyper-futuristic monument that would dominate every other structure on the mainland. He hired director Wang, a legendary structural architect known for pushing geometry to its absolute limits. Wang went back to first principles. A skyscraper, at its core, is a structural conduit between the earth and the heavens. He reached for 2 of the oldest geometric motifs in local philosophy: the square prism, representing the grounded structure of the earth, and the circle, representing the infinite expanse of the sky. He stacked them. The tower would rise as a square base, its sides gradually tapering and intersecting until they converged at the summit, where a massive 46-meter circular void would pierce the structure. It was bold. It was high-tech. It was aerodynamically brilliant. The blueprints were finalized, the municipal approvals were signed, and in 1995, the heavy pile drivers slammed into the Shanghai soil. It was full steam ahead, until the money vanished. Music drops out low. Ominous drone in 1997, the Asian financial crisis struck the region like a tectonic shockwave. Overnight, hyperinflated credit markets seized up. The massive lines of capital funding Chairman Li's empire evaporated. The mega project didn't just slow down. It suffered a total catastrophic freeze. The pile drivers went silent. The workers walked off the site. For years, the plot sat as a gaping, flooded concrete scar in the center of Pudong. A half-finished monument to an economic boom that had outrun its own reality. For nearly 7 years, the foundation sat dormant, gathering rust and rainwater, while the rest of the world wondered if the Great Tower would ever rise out of the mud. And by the time the capital was secured and the cranes finally turned back on in the early 2000s, the world had fundamentally changed. The engineering metrics had shifted, the safety rules had been rewritten in blood, and a massive structural crisis was brewing beneath the soil. Music effects. Upbeat, aggressive electronic industrial beat in narrator. When the heavy construction cranes finally woke up in 2001, the engineering landscape of the mainland had been completely upturned. The race for the sky was no longer a leisurely marathon. It was a high-stakes, hyper-accelerated sprint. Down south in Shenzhen, new megastructures were piercing the cloud line. Up north in Beijing, radical structural forms were being approved for the upcoming international events. Chairman Li and Director Wang stood over the stagnant, waterlogged foundation pit in Pudong and realized their original 1995 blueprint was already obsolete. If this tower was going to stand as the undisputed crown jewel of the financial district, it had to be bigger. It had to be bolder. The original design called for a height of 460 meters across 94 floors. Chairman Li made an executive decree, push it to 492 meters, add 7 more stories, make it 101 floors. Give it the highest occupied floor plate on the planet. There was just one terrifying, multi-million-dollar problem with that ambition. The foundations were already deeply embedded in the earth. Sound effect. Deep, underground rumble. You cannot simply add 32 meters of structural steel and thousands of tons of high-strength F concrete to a super-tall building on a whim. The foundations of a skyscraper are matched to its mass with mathematical precision. In the Pudong district, this calculation is a matter of life and death for a building. The local geology is not solid granite. It is soft, shifting river silt, clay, and sand deposited over millennia by the Yangtze River Delta. It is effectively a subterranean marsh. To keep a massive tower from sinking into the earth, engineers have to drive hundreds of high-strength steel friction piles deep into the soil layers, capping them with a massive, solid concrete foundation raft. For this tower, the existing foundation consisted of over 2,000 steel matrix piles driven up to 78 meters deep. Bound together by a thick concrete mat, those piles were engineered to carry the exact weight of a 460-meter building. If you slam an extra 32 meters of skyscrapers on top of that specific foundation, the structural load increases exponentially. The soil layers compress unevenly. The building begins to experience differential settlement, sinking millimeters at a time on one side, tilting the entire vertical axis, tearing the glass curtain walls apart, and threatening a catastrophic structural failure. Sound effect, metal tension snap. To solve this nightmare, the development team brought in Chief Engineer Zhang, a legendary figure from the China Academy of Building Research. Zhang looked at the data and delivered a brutal ultimatum. You cannot strengthen the foundations already buried under the mud. If you want to make the tower taller and wider, you have to find a way to make it weigh significantly less. You must build a heavier silhouette, but shed thousands of metric tons from its structural skeleton. What followed was one of the most intense, high-tech redesigns in modern architectural history. Zhang completely ripped out the traditional heavy concrete core system that was standard for continental supertalls. Instead, he engineered a revolutionary hybrid skeleton. He wrapped the exterior of the tower in an innovative diagonal braced frame, a massive perimeter web of structural steel outriggers and mega braces that formed an external exoskeleton. This diagonal system was so incredibly efficient at transferring loads that it allowed the engineering team to thin out the massive internal concrete shear walls by several inches across all 101 floors. Sound effect. Computer architectural scamping. Every single millimeter of reduced concrete thickness stripped away thousands of tons of dead weight. Zhang's team then replaced standard, heavy flooring units with lightweight composite steel decking. They optimized the structural steel perimeter columns, utilizing advanced computer modeling to shave off excess metal where the stress profiles were lowest. The results were a triumph of structural mathematics. By wrapping the tower in this high-strength diagonal matrix, they cut the overall dead load of the building by a staggering 10%. They didn't just save the existing foundations from a catastrophic settlement failure. They actually reduced overall material costs and accelerated the construction schedule. Because the external exoskeleton carried the bulk of the lateral wind forces, the interior floor plates could be cleared of massive, view-blocking columns. What should have been a terminal design flaw was transformed into a spacious, premium commercial layout. With the foundation crisis solved, the tower began to rise at a blistering pace. Floor by floor, the mega-braced frame climbed past 200 meters, then 300 meters, devouring thousands of cubic meters of specialized high-performance concrete every single week. The local housing bureau and the Municipal Construction Commission ran constant checks, monitoring the millimeter-precise lasers for any signs of subterranean shifting. The building was perfectly balanced, rising true and straight into the Shanghai sky. Music intensifies, alarming, driving electronic. But as the tower approached its final, defining phase, the construction of the massive upper crown, it ran headfirst into an invisible wall that no software could calculate, and no structural brace could withstand. It was the year 2005. The structural steel was climbing into the upper 80 stories, and the outlines of Direct Wang's grand 46 meters circular wind void were finally becoming visible from the streets below. That was when the fuse was lit. A sharp, critical editorial was published in a prominent local daily newspaper. The headline asked a single devastating question that instantly rippled across the early local internet forums. Why is a major commercial developer allowed to carve a massive, unmistakable rising sun directly into the historic skyline of our financial capital? Sound effect, Kama flash, overlapping Saren echoes. To the design team, that circle was an homage to ancient heritage, a functional moongate engineered to let storm winds pass harmlessly through the building's crown. But to the public looking up from the historic streets of the city, the symbolism was completely different. The circle, paired with the fact that significant chunks of the project's financing had been structured through complex international investment consortiums linked to prominent regional tycoons, was interpreted as a deep cultural insult. The city still held living memories of wartime occupations and painful historical conflicts from the previous century. To see a giant, circular void that perfectly mirrored the aesthetics of a foreign national flag planted at the highest point of the metropolis was an intolerable sight for millions of citizens. The online outrage spread like wildfire, overwhelming the early digital bulletin boards. It wasn't just a localized internet complaint. The anger reached the highest levels of the municipal administration. The local construction bureau received thousands of letters. The mayor of Shanghai himself formally raised objections, noting that a building of this scale becomes a permanent public monument, and its symbolic impact cannot be separated from the collective memory of the nation. Director Wang and Chairman Li were summoned to an emergency meeting behind closed doors at the Municipal Construction Commission. The directive was clear, unyielding, and absolute. The circle must die. If the builders did not alter the design of the tower's crown immediately, the final occupancy permits would be permanently withheld. The nearly completed structural masterpiece was facing a total, permanent shutdown. Music shifts, low, tense, an electrical undertone with pulsing synth narrator. The crisis at the top of the Pudong Tower wasn't happening in a vacuum. To understand why the Municipal Construction Commission and the local Housing Bureau were so incredibly hyper-vigilant about a structural alteration mid-construction, you have to look at the broader landscape of the mainland's hyper-accelerated urbanization. This was a period where mega-tall engineering projects were pushing structural materials to their absolute physical limits. Across every major domestic hub, from the coastal shipping ports of Guangzhou and Shenzhen to the surging river metropolises of Wuhan and Chongqing, towers were climbing faster than the regulatory codebooks could be updated. And when you build that fast, in conditions that extreme, even the smallest miscalculation in geometry, soil dynamics, or wind engineering can result in a multi-million-dollar catastrophe. Sound effect. Distant crash. Metal rumble. Take a look down south at the high-rise corridors of Shenzhen. Years after the Pudong crisis, the engineering world would be rocked when a landmark 70-story steel and glass skyscraper began to violently sway and vibrate out of nowhere. There was no earthquake. There were no high typhoon winds. Yet thousands of office workers were filmed fleeing the building in sheer panic as desk chairs rolled and light fixtures swung from the ceilings.
The municipal authorities immediately sealed off the site and brought in structural teams from the China Academy of
Building Research. What they discovered sent a chill through the entire high-rise construction industry. The culprit wasn't a broken column or a fractured weld. It was a phenomenon known as vortex shedding, combined with a subtle structural resonance. As the wind slid around the sharp edges of the tower, it created alternating low-pressure pockets, causing the building to vibrate in harmony with its own structural frequency. The fix. Engineers had to completely strip down the building's roofline and install massive, heavy-tuned mass dampers and structural modifications to change how the wind interacted with the summit. It proved a vital lesson that every modern engineer knows but fears. The crown of a super-tall tower is its most aerodynamically vulnerable zone. If you mess with the top of a skyscraper, you mess with the physics of the entire structure. Sound effect. Drilling and concrete mixing, and the dangers weren't just limited to the wind. Go west to the soft, waterlogged riverbanks of Wuhan and the mountain slopes of Chongqing. In Wuhan, developers building along the muddy banks of the Yangtze River ran into the exact same subterranean nightmare that faced the Pudong team, hundreds of meters of shifting, unstable river silt. In several high-rise developments across the mainland, a phenomenon known as adjacent excavation settlement has caused catastrophic failures. There have been documented cases where developers dug massive underground parking garages or subway line connections right next to existing high-rise foundations. The shifting of the underground water table caused the surrounding silt to liquefy. Within days, massive luxury apartment blocks began to experience severe structural cracking, with some tilting several centimeters out of alignment, forcing emergency evacuations, permanent occupancy bans, and total structural demolition before the buildings were even finished. Sound effect. Glass curtain wall shattering. Then there is the structural hazard of the glass curtain wall itself, a major engineering focus across Beijing and Tianjin in dense urban centers when a 400-meter tower experiences wind buffeting. The immense thermal expansion from daytime solar heating, combined with structural twisting, puts incredible stress on the glass panels. If the window frame joints are engineered with even a millimeter of tolerance error, the glass panels buckle and explode, raining lethal shards of heavy, tempered glass down onto the crowded metropolitan streets below. This was the volatile engineering reality that Director Wang and Chief Engineer Zhang were dealing with when the order came down to eliminate the circular void. They weren't just changing a decorative pattern on a drawing board. They were altering a vital aerodynamic valve on a building that was already 80 stories in the air. Music intensive, drifting, high stakes, drum beat. The original 46-meter circle was not a cosmetic choice. It was a highly sophisticated engineering solution designed to mitigate the drag coefficient of the tower. When a massive typhoon rolls in from the East China Sea, it slams into the flat face of a skyscraper with hundreds of tons of lateral force. By carving a giant, open void at the summit, Director Wang had allowed that immense wall of air to cleanly pass through the building rather than pushing against it. This simple hole reduced the total lateral wind load on the upper structure by up to 30%. If they simply filled the hole with solid concrete and glass to erase the symbol, the tower's wind resistance would skyrocket. The extra surface area would catch the typhoon winds like a massive sail, transferring millions of newtons of torsional twisting force down through the structural skeleton, overloading the diagonal braced frames and overloading the fragile friction piles buried deep in the Pudong mud. They couldn't just fill it in. They couldn't just erase it. They had to invent an entirely new geometric shape that would appease the public, satisfy the strict cultural memory of the city, and still maintain the exact same aerodynamic wind tunnel efficiency as the original circle. Director Wang locked his team of structural architects in a design room with high-powered computational fluid dynamics simulators. They had to redesign the crown of one of the tallest buildings on Earth mid-flight, while the entire nation watched every single move from the ground below. They needed a miracle of geometry, and they needed it before the rising concrete frame reached the point of no return. Music shifts, intense, industrial writhe, heavy percussion with a ticking clock metronome narrator. Inside the high-rise command center in Pudong, the atmosphere was thick with exhaustion and panic. The year was 2005. Outside the windows, the massive structural steel skeleton of the tower had already punched through the low-hanging clouds, climbing past the 380-meter mark. But on the drafting tables of Director Wang and Chief Engineer Zhang, progress had completely ground to a screeching halt. The Municipal Construction Commission's decree was an absolute, unyielding wall. The circular opening could not be built. Every single day the crane sat idle or slowed down, cost the development consortium hundreds of thousands of dollars in interest, holding costs, and labor fees. The early internet forums on the mainland were tracking the site daily, with citizen journalists snapping photos from the ground, waiting to see if the builders would defy the city or capitulate to public demand. Director Wang was facing the ultimate architectural nightmare. He had to tear open the blueprints of a hyper-complex super-tall structure while it was actively being assembled in the sky. Sound effect, metal papers rustling, computer keyboard clacking. Let's be absolutely clear about what a structural change of this magnitude actually means on a live construction site. This isn't just about deleting a line on a computer screen. At 400 meters in the air, a super-tall skyscraper is an incredibly delicate, interlocking ecosystem of weight, tension, and aerodynamics. The structural steel components for the upper floors, the massive, custom-forged perimeter columns, the heavy outrigger trusses, and the diagonal mega braces had already been manufactured, cast, and numbered in heavy industrial foundries across the neighboring industrial zones of Jiangsu and Zhejiang. These multi-ton steel members were sitting in logistics yards along the Huangpi River, waiting to be hoisted into the clouds. If the new design changed the load-bearing paths by even a fraction of a degree, every single one of those custom steel pieces would become completely useless junk metal. Director Wang's initial attempt to save the architectural soul of his building was a frantic compromise. He proposed keeping the 46-meter circular void, but retrofitting a thick, horizontal pedestrian skybridge directly across the bottom arc of the circle. His mathematical reasoning was that the solid line of the bridge would break up the perfect round silhouette, making it look less like a rising sun flag and more like a functional infrastructure element. Sound effect: low, resonant. He presented the sketches to a tense, closed-door panel consisting of the local housing bureau, the Municipal Construction Commission, and neighborhood community representatives. The reaction was cold and immediate. An elderly local resident, a man named Mr. Chen, who had lived through the chaotic urban conflicts of the mid-20th century, stood up, looked at the blueprint, and shook his head. He told the designers that a line across a circle does not erase the circle. It just looks like a rising sun behind a barrier. The public wound was too deep. The symbolic association was absolute. The bridge was rejected. The engineering team went back to the drawing board under a state of total lockdown. Chief Engineer Zhang ran non-stop simulations on the firm's advanced computational fluid dynamics mainframes. They tested squares, rectangles, triangles, and complex polygons, a standard square void was tested first. It looked clean, but the physics were a disaster. The sharp 90-degree corners of a perfect square created massive structural stress concentrations at the interior joints. When heavy typhoon winds slammed into the building, the air currents would violently eddy inside the sharp corners, creating massive localized turbulence and structural fatigue that could rip the perimeter glass curtain wall right out of its structural tracks. Sound effect. Computer simulation. Alarm. That was when Director Wang discovered the ultimate geometric loophole. He realized that if they stretched the top and bottom lines of the opening and angled the sides inward, they could create a massive, elegant trapezoid. A trapezoidal aperture. To the public looking up from the streets of Shanghai, the trapezoid completely obliterated the rising sun imagery. It looked entirely industrial, futuristic, and functional. But to the engineers, the trapezoid was an absolute masterpiece of fluid dynamics. The sloped, angled sides of the trapezoid acted like a giant aerodynamic funnel. Instead of fighting the wind, the trapezoidal opening compressed the incoming air currents, accelerating them smoothly through the tower and cutting the building's overall drag coefficient even more effectively than the original circular moon gate design. The music intensifies. Triumphant but aggressive electronic beat. When Chief Engineer Zhang looked at the structural stress models for the trapezoid, he realized they had stumbled onto a massive logistical jackpot. And here is the exact detail that almost every single amateur documentary and casual observer gets completely wrong about this building. The opening did not become a square. It became a flat-bottomed, tapering trapezoid. And that trapezoid didn't just save the project from a political shutdown. It made the building significantly better from a commercial and financial standpoint. Because the sides of the trapezoid angled inward as they climbed toward the roof, it actually increased the usable interior floor space on the 97th, 98th, and 99th stories. In the original circular design, the curved walls created awkward, unusable wedge-shaped voids at the edges of the high-level floor plates. The flat, structural planes of the new trapezoidal crown allowed the developers to maximize every single square meter of real estate at the absolute peak of the tower. Chairman Li immediately capitalized on this layout change, using the newly recovered square footage to expand the luxurious, glass-walled atrium layout for the ultra-premium hospitality suites occupying the summit. Furthermore, the straight structural lines of the trapezoid meant that the structural steel fabricators could use simpler, standardized box girder connections rather than the hyper-expensive custom-curved steel castings required for a massive circle. The structural revision actually slashed millions of dollars off the final upper stage structural fabrication budget. Sound effect. Wiring crayons, air compressors. Drilling. In late 2005, the Municipal Construction Commission officially signed off on the revised trapezoidal blueprints. The green light was given. The heavy diesel engines of the tower cranes roared back to life at full throttle. Steel crews working in freezing high-altitude winds began pinning the massive trapezoidal trusses into place 400 meters above the Huangpi River. The frantic mid-flight redesign had worked. The building was climbing once again, its new silhouette taking shape against the gray industrial sky. But as the structure raced toward its final topping-out ceremony, a whole new engineering battleground was opening up. The tower was about to come face-to-face with its neighboring giants in a high-altitude turf war for the ultimate prize, the title of the tallest building on the mainland. And the decisions made in those final months would redefine how the world measures the true height of a skyscraper. Music shifts, grand, sweeping elevation, high-stakes orchestral synths with deep drum reverbs narrator. By the time the final structural steel beam was bolted into place in August 2007, the Shanghai World Financial Center had successfully weathered an economic collapse, a foundation weight crisis, and a high-stakes cultural redesign that completely altered its architectural crown. But as the finishing touches were being applied to the gleaming glass curtain wall for its grand opening in 2008, the Megas project found itself standing on the precipice of one final, highly calculated dilemma. The tower stood at an immense 492 meters to its structural roofline. It had officially secured the title of the highest occupied floor plate anywhere on the mainland. It boasted the highest observation deck on Earth, a breathtaking glass skywalk suspended 474 meters above the Pudong streets, right at the top edge of that newly engineered trapezoidal void, by every functional, human metric of architectural height, where real people actually work, dine, and look down at the clouds. This building was the undisputed champion of the skyline, but it did not hold the technical title of the world's tallest building. Sound effect. Wind howling at high altitude. Just a short flight away across the strait, another regional megatower, Taipei 101, had laid claim to the absolute height record at 508 meters. But it had achieved that number through a highly controversial engineering loophole, a massive 60-meter decorative steel spire pinned to its roof like a giant radio needle. Director Wang's design team sat in the executive suite of the newly finished Pudong Tower. Looking over the final global ranking criteria, they realized something fascinating. If they wanted to steal the absolute crown from their regional rival, they didn't need to rebuild the core. They could easily manufacture a pair of lightweight, high-strength structural steel spires, hoist them up through the trapezoidal aperture, and anchor them to the building's highest outrigger trusses. With just a few extra tons of decorative metal, they could push the total height of the bottle opener past 510 meters, seizing the ultimate global record and etching the building into the international record books forever. Director Wang went to Chairman Li with the proposal. The response he received is an absolute masterclass in urban restraint. Chairman Li looked out the floor-to-ceiling glass windows, down at the sprawling, hyper-dense metropolitan grid of Shanghai, and shook his head. He said no. The tower was designed to be a broad-shouldered, elegant monument, a clean, tapering column of glass and steel that seamlessly bridged the earth and the sky. To tack a thin, artificial needle onto the roof just to chase a fleeting vanity metric would completely ruin the structural integrity of its silhouette. They chose to let the title go on purpose. Sound effect, low, resonant, mechanical, chime, and history would quickly prove them entirely right. Just 2 short years later, in 2010, an absolute monster of a hyper-tall project, the Burj Khalifa, would open in Dubai at an astronomical 828 meters, pushing the world's tallest record so incredibly far out of reach that the global height race instantly lost all practical meaning. By refusing to compromise the clean, iconic lines of the trapezoidal crown for a temporary record, Director Wang and Chairman Li ensured that their tower would remain a timeless, authentic piece of structural art rather than an outdated curiosity. Today, the Shanghai World Financial Center stands as a monumental triumph of mainland civil engineering. It didn't just survive its crises, it thrived because of them. The unique trapezoidal slot that the city initially demanded out of profound historical grievance has become the very feature that defines its identity. The bottle opener is no longer a term of derision. It is a badge of urban affection. Music intensifies, triumphant, driving phenol, look at where it stands right now. It forms 1/3 of the most spectacular high-rise trio on the face of the earth. It stands shoulder to shoulder with the tiered, pagoda-inspired Jinmao Tower and the soaring 632-meter twisted helix of the Shanghai Tower. This marks the first and only time in civil engineering history that 3 distinct super-tall skyscrapers have been intentionally clustered directly adjacent to one another in a single metropolitan center. Each tower represents a different phase of architectural philosophy, a different era of the mainland's rapid economic evolution. But the 492-meter bottle opener remains a permanent monument to a much quieter, deeper truth that every developer and structural engineer must eventually learn to respect. A skyscraper is never just an arrangement of high-performance concrete, diagonal-braced frames, and wind tunnel mathematics. The moment a building climbs past 300, 400, or 500 meters into the sky, it ceases to be private real estate. It becomes a permanent, public symbol. It becomes a physical part of the collective identity of the metropolis that surrounds it. And the millions of people who live, work, and walk beneath its massive shadow every single day get a permanent, defining vote on what that symbol is allowed to say. You can pour the most precise mathematical formulas into a super tall blueprint. You can calculate the exact millimeter of soil settlement, the exact kilonewton of wind load during a Category 5 typhoon, and the exact structural elasticity of a glass curtain wall. But at the end of the day, the heaviest, most volatile load a megastructure will ever have to carry isn't the weight of its steel or the pressure of the wind. It is meaning. Somewhere right now, on a drafting table in a major urban hub, another team of eager architects is sketching another bold geometric symbol into another soaring skyline, absolutely certain they understand exactly what it means. But the vital question that stopped this 101-story titan halfway to the clouds remains buried inside every single monument ever conceived by human ambition. Who actually gets to decide the true meaning of a building? Is it the visionary architect who draws the lines? Is it the billionaire developer who signs the checks? Or is it the millions of citizens who look up at the clouds, remember their history,